We are building the Fractals and Recursion program from the YByte Python curriculum, available at www.ybyte.in. We have seen how we can use recursive codes to create some pretty interesting patterns. For example, previously we saw how we got this, squares of different sizes. So I have a basic function to draw a square, and then I have this recursive call. Now, obviously, we can change the location, let's say, of the subsequent squares. For example, let's say I do not add the plus L to both of these. So basically, it's like X and Y, same location at the same X and same Y. When I, let's say, call this function now, and I, let's say call, say, square, notice the squares as expected become into each other because the X and Y position is not being changed. So I'm just drawing a bigger square, then a smaller square, and so on and so forth. In fact, I can see this more clearly by, say, clearing all this and calling it with slightly bigger, let's say, dimensions. So I say -100, -100, and let's say at 200. So when I do this, the first square is bigger, but subsequently everything keeps going inside. We can try, in fact, one more thing here. Let's just say I do, well, look, X plus, say, maybe 3/4 times L, and Y plus, let's say, L/4. So what I'm doing is that, I'm moving, remember X and Y is the corner here. So I'm moving the second square to, let's say, 3/4 this distance and moving up 1/4 this distance. When I do this now, basically I get, let's say, so when I call, let's say, this function, notice my subsequent squares are sort of a little bit interlock type. So, I get, let's say, like I said, move 3/4 the distance here, 1/4 the distance in Y, and that's why I end up. And I keep doing this. It looks pretty cool. Why does this exactly happen? Well, like I said, I'm doing 3/4 times L, Y plus L/4. So -100, -100 was the starting point of the first square. The second square starting point is 50 -50, because remember, -100 plus 200 times 3/4 and -100 plus 200/4. So that's this square, and next square is of length 100 as earlier, then take 50 and so on and so forth. Now, obviously, I can do this in the reverse order, and it's actually quite interesting to see. So I will just go and, let's say, do this right now for illustration. So if I were to do this in the reverse order, as we had seen previously, basically I expect the smaller square to get drawn first, and indeed that's what happens. The whole thing gets inverted. Notice the smaller square first, then the bigger square till the last square. But obviously the locations of the squares do not change because we are just changing the way we are calling the recursive function. We're not changing the arguments inside that. In fact, on that note, I could have also just done my, I could have, let's say, just this as we had done before. Again, when I were to run this piece of code, the outcome is the same, but notice the smaller square got drawn first, then the bigger square, and so on and so forth. So, basically the point I'm trying to make is that we can create many patterns even with just this. So I'll just go back to, let's say, say plus, say, 3/4 L, 3/4 times, let's say, L, and let's say Y plus 1/4 times L. You can, of course, play with this. You can change the way L changes. So instead of L/2, probably you may want to do L/3, and let's say put a round number or something like that. Experiment with this. That's interesting. But I'll just go back to this for my subsequent development. I'll just run this once to make sure it's all fine. When I do this, for instance, let's say I call this, as expected, I get these interlocking squares. Looks pretty cool. But you must be wondering, okay, all right, this is good, but this looks something that I could have easily done with a single for loop. In fact, we did see examples of recursion, but you may still be wondering that, why are we doing all this? What's so special about this, right? Well, hang on, because what we are going to do next is where recursion really starts to show its role. Basically, we will start to call this recursive function not once, but more than once. And the moment we do that, we realize that the outcome is not just, let's say, fascinating, it's also quite surprising. And it's just amazing to look at how recursion takes over, and we get so much done with just one extra line of code. And that's where we are going to go next. And I hope you are enjoying this journey. YByte has a very, very unique way of teaching Python, where we build activities, we analyze them in detail, and we move things in a very, very step-by-step manner. So look at our website, www.ybyte.in, for many more such lessons. Take care. Thank you so much. Bye-bye.